Good afternoon. This is Corey Hysoon from the IACD team. Welcome to today's IACD webinar. We're happy to have Mr. Nam Lee with us. Nam is the IACD integration team lead and is going to share his insights on his work implementing integrated and adaptive automated processes that cross organizational boundaries. I'll be following online if anyone would like to post questions during the presentation, and we can follow up the presentations with any questions. Feel free to post any questions in the comment section. And without further ado, Nam, the floor is yours, sir.
Thanks, Corey. As I said, as was stated earlier, my name is Nam Lee. I'm the integration team lead here at IACD, the IACD program here at Johns Hopkins University Applied Physics Lab. For those who aren't familiar with the IACD program here at APL, we perform research experiments in 90-day spirals with the hopes of advancing the state-of-the-art in cyber defense. I've been with the program here for almost 5 years, and I'm excited to share some of our findings from a previous spiral. Today I'm going to highlight some of our research into automation and orchestration with a focus on integrating SOC and IT operations. Oops. So I just want to start by talking about the current landscape. As most of us already know, security orchestration, automation, and response, or SOAR, platforms have been, growing in popularity, being adopted out in industry, and they've brought automation and orchestration to SOCs, everywhere. However, automation and orchestration isn't really new. It's been part of IT administration for quite some time through tools such as Ansible, Puppet, and Chef. So those tools have existed for quite a while, so that's not really anything new for the IT guys. And within an organization, you've typically got, your security operations center, your network operations center, as well as your IT asset managers. All these different groups typically are run, separately and, don't really integrate that well, and they operate independently and oftentimes have different tools and processes within their own organization. Even at APL here, our own organization, there's minimal collaboration between all these entities. So typically a SOC analyst who gets some threat intel or does some threat hunting will find the issues, and for simple things, they'll typically do a simple response action like creating a firewall rule or doing some DNS black holes or what have you. But for anything that's more complex in terms of remediation, they're going to have to go through and create a ticket and throw it over to the IT guys to take a machine offline and actually do the remediation on the box itself. So this handoff is often manual and error prone, and we wanted to explore how can we better improve this process through automation and orchestration. So for our experiment design, given what we know about SOCs, NOCs, and IT operations, IACD wanted to explore how we can combine the powers of SOAR platforms with IT automation tools. We wanted to extend that security automation past just the SOC and into the IT operations, automating processes that can cross these organizational boundaries and involve multiple stakeholders. We wanted these two groups to really collaborate and use the cyber threat intel from a SOC to help prioritize some of the tasks that are given to the IT group. And then lastly, we really wanted to explore what cyber threat intel is most impactful for the network defenders. That was sort of a side benefit of this, to really go beyond what a traditional indicator of compromise can do. What can we do to pass on information that's more useful to the IT operations? So those were our main objectives for the experiment. We'll get into the next portion, which is the experiment design. So to get our SOC and IT groups to collaborate, we've chosen a use case where we receive some cyber threat information from a threat intel analyst and use that data to prioritize what gets patched by the IT asset managers. Now, even within our own organization here at APL, our IT group is, continually patching stuff on a weekly basis. They don't really get involved with the SOC, and the SOC doesn't really get involved with what's happening on the IT side in terms of what things get patched. They just do their normal routine. So for our experiment, we're kind of simulating the need for an emergency patch, something like a heart bleed or along those lines where we know the vulnerability is actively being exploited in the wild and we really need to address it immediately instead of waiting for that patch cycle to happen. So here's just a high-level overview of that particular scenario. We receive a STIX message that provides a common vulnerabilities and exposures or CVE data that includes some information about a particular application being exploited in the wild. We use this CVE data to prioritize the remediation of the vulnerability, help to identify which assets within our environment are vulnerable, and then pass that information on to the IT operations people to remediate it. Then we'll leverage the IT automation tools to patch those applicable systems. And then we'll rescan the network to sort of validate that all of that happened and the patching was successful. And throughout the process, we track it using a ticketing system to help with tracking and auditing of this process. Here's a list of tools that we used within our experiment. For our SOAR platform, we use Swimlane. We've used a number of different SOAR platforms here on the integration team. We just selected Swimlane as one we haven't used too recently, so we wanted to see what its capabilities were. We used Tenable's vulnerability scanner, Nessus, to provide vulnerability information to identify which OSs and applications are within our environment and what patch level they're at. We use their Security Center tool as sort of a manager and go in between for Swimlane to talk to Nessus. And then we use a product called Kenneth Security, which is another asset management tool, but in addition to vulnerability management, it does risk analysis as well. So it helps to sort of triage and prioritize the remediation efforts based on this risk scoring that it does. And then for the patch management side, we've got Microsoft System Center Configuration Manager, or SCCM, to help with patching the Linux side or Windows side, and then Ansible, which is a Linux IT automation tool. That coupled with a Yum repository we would use for the Linux patching. And then for our ticketing system, we used ServiceNow to help keep track of everything that was going on throughout the process. So as I mentioned earlier, we use STIX to pass CVE information into the SOC. We used STIX 2.0 format because it has a STIX object, a vulnerability object, in which we can place some of the CVE information in. And then for this particular experiment, we decided to go with CVEs where the remediation or solution was just to patch or upgrade an application. That made it easier for automation to take over and just remediate. We realized that there are many CVEs that contain remediation instructions that require multiple steps and might be more complicated and involved and might need some sort of natural language processing or ML or AI to sort of automate those remediation efforts. So we sort of scoped it down to something that was more manageable for our team to accomplish within the 90 days. Here you can see a little example of the STIX bundle that we passed through with the vulnerability object and the name of the CVE and sort of a description of what things need to get patched. So we had to modify this description field within the STIX object. This description field is mainly for unstructured text. So we just had to come up with a format to specify exactly what version of the application needs to get patched and to which version. So in doing so, we can apply the automation appropriately. So here's a more detailed breakout of the experiment workflow. Again, we start out with this sticks message containing a CVE. We use swim lane to process that sticks message and parse it out, create a ticket within ServiceNow with all of that information. And then swim lane then kicks off a automation workflow that then retrieves the list of assets based on that CVE information that are really applicable from Kenna. Kenna provides a risk score, and so we can kind of see which assets we need to prioritize in terms of patching. We'll update the ticket with the list of assets that need to get patched, and then for each asset, we'll check which operating system it is, and then throw it down a particular path to get it patched. So for the Windows side, we would manually take the latest version of the software that needs to get patched, put it into SCCM, and then from there kick off the patch using automation within SCCM itself. On the Windows side, we would update our Yum repository with the updated version of the application, and then use Ansible to schedule the pushing out of that patch to our Linux machines. Once all of that's been done, we update the tickets with all the actions that have been taken in terms of patching for all of our assets. Then we use Nessus to rescan our assets to make sure that the patches have been applied and the vulnerabilities have been remediated. And then we retrieve the Nessus scan, import it back into Kenna so we can update our risk scores, and then update the ticket with our new risk scores. And that pretty much ends our workflow. So for our experiment results, we were able to automate a significant portion of these processes. Most portions of the workflow took very little time. Patching in SCCM took about 3 minutes. Ansible took less than 10 seconds. The long pole in the tent was Nessus taking that scan to rescan everything, took about 15 minutes. And what we really found was that the APIs are really important to allow and enable the automation and orchestration to really take hold. Building the workflows within swim lane, most of the integrations were very straightforward. We had to build something for Kenna since they didn't have a specific integration point with the Kenna security product. Overall, the process was pretty straightforward in terms of building out the automation. So to get a little bit better idea of how the workflow executed, we've broken out some of the workflow execution times here. So that's first step of sort of processing the sticks message, creating a ticket, querying Kenna with for all the assets that are applicable. Took about 10 seconds, pretty quick. And then moving on, manually adding the software to SCCM and the Yum repository so that it can be scheduled for patching. That took, about 10 minutes. That sort of is going to vary because it's a manual process, but at least these two things can happen in parallel for the Windows and the Linux side. But we estimate, an analyst or IT guy can sort of put those, download the patches and put them into those patch management systems within about 10 minutes. And then updating the installed software took about 3 minutes. Now I'll note that we did a special configuration with our SCCM to push the updates after 3 minutes. The default configuration for SCCM, pushes updates after 60 minutes. So that would increase the times depending on how an organization has their SCCM configured. And then the rescanning of Nessus took about 15 minutes, getting all that information back into Kenna to update the risk scores, and then updating the risk scores and ticketing information to sort of finish out the workflow. It took another 10 seconds. So overall, it took about 39 minutes to execute the entire workflow, which is pretty good. Knowing that number might vary depending on how different configurations are and how quick our IT operations staff are responding to tickets in terms of doing the manual updates. But ultimately, the research showed that automation and orchestration can be applied to this use case involving multiple stakeholders within an organization. And while we couldn't automate the process all the way through, we still needed to sort of manually put those patches into the patch management system. We found that there's still value in automation portions of this process. Adding the IT automation tools to augment security automation through the SOAR platform really helped to reduce the overall timeline for this process. Having the cyber threat intel contain CV information provided more actionable threat intel over a traditional IOC. So once we were able to remediate this particular application, any malware that might take advantage of this vulnerability will be covered instead of just blocking a particular indicator, such as like an IP or a domain. And while CV remediation can take multiple steps a lot of times and might not all be automatable, we still believe automating the triage and the prioritization aspects of this workflow provide great value and really help with our operations. The key here being, how the organizations calculate their risks and having enough detailed information for their assets and their environment to really help that process. Other issues we didn't really address in this experiment were, how to verify that a patch didn't adversely impact an organization's operations. We sort of hand-waved that and left that to figure out as follow-on research. We know, other organizations might test deploy into a sort of a test environment, have some users test out the patches before fully rolling out into an operational environment. So that's one way. And then other things that we can look to address are, maybe with an organization that has more homogeneous builds for their environment, maybe the process might involve updating a gold image and redeploying a gold image out to all the endpoints. And so, lastly, we, as I mentioned, we use sticks to sort of hold that CV information. The sticks vulnerability object in sticks version 2.0, it wasn't ideal for machine consumption in the way that we sort of shoved our data into the description field. So it didn't lend itself to automation so much. We just had to, provide some format so that the automation could consume it and do the right things. So some additional research probably should be done to figure out how best to format that data to really enable machine consumption and automation. So that was sort of a high-level, sort of brief overview of our experiment and our findings, and we really think that automation and orchestration really provide additional value, and you can apply these to a lot of different processes within your organization. And that's it for me. Thanks for attending the webinar. Be sure to check for us on social media. Go ahead, Corey.
Okay. Thank you so much, Nam. Again, we're all very grateful for your time today and for sharing your valuable insights and lessons learned from your work. Particularly excited to see how straightforward setting up the automation was for you and the impact to execution times and the sticks information too, the CVE. For everybody, this webinar will be made available on our channel shortly after we're finished. Please subscribe to our channel to receive notifications as additional webinars and other videos are posted. Thank you again, Nam, and for everyone else for joining us. We'll see everyone next time. Take care and goodbye.